In this introduction to this lesson, students are asked to create a relative frequency histogram, and that's what I have here from the data. The data is, in this problem, is from the hundreds of dollars put into an ATM or withdrawn from an ATM for 30 days. And so since it's hundreds of dollars, for example, the first data point would be 7,200, so 7,200. And the highest value you see there, the maximum, is 10,400. The minimum you see there in the data set is 6,100, I think was the lowest value. And so if you're looking at the histogram, it said, or the data points, the first question they asked for after creating the relative frequency histogram was, if you put $9,000 in the ATM each day, what percent of the days in a month should you expect to run out of cash? So you can see that they do it for security reasons, but you can see that on some days there is actually people trying to withdraw more than the $9,000. So like the first data number that you run into, 10,400 would be above, 9,200 would be above, the 92 representing 9,200, and anything above 90, which there's not even a 90 in the data set because that would represent 9,000, anything above that would be, and there's 5 of those values out of 30. So 5 out of 30, and that's going to be approximately 0.167, and so that's 16.7% of the days you would expect to run out of cash. And then I asked them on the next graph to create a cumulative frequency histogram. Well, what they're going to have to do is, on cumulative frequency histograms, you create intervals that always start with the beginning number of 60, if that's where we start again with this value. So if I were to kind of model that, even though they're supposed to do it on a different graph since I only have this one screen, well, the first value would be this. If this was the beginning of the cumulative frequency histogram, we would say that that's 60 to 65. Let's say that that's the first interval, so anything from 60 to 65 would still go to 1. Let's just create a bar there. So 60 to 65 would still only go up to 1. But then on the next bar, they would have to put, okay, 60 to 70. So it would start back over, and I don't have enough room really here to write out the intervals. But it always starts over at that beginning number. So now what would you put for 60 to 70? Well, you have to include the one you already have. And then you can see from 65 to 70, they added one more. So now it would go up to 2. And so now you're going to add 1 plus 1, and it accumulates. And then the next the interval would be 60 to 75, and you would write them underneath the intervals. I'm just having problems writing them on this iPad, but 60 to 65, well, 60 to 65, if I add all of those together all the way up to 75, would be 1 plus 1 plus 4, and that's going to add up to 6. And that's how they're going to keep going, that they keep accumulating when you create and you always start with that beginning number of every interval. And that just keeps accumulating. So when I ask the question later for them to find the difference between the bars on the histogram, the cumulative frequency histogram, for example, this third bar, if I took it and took 6 minus the 2, that would leave me 4 for the difference right here. And that would show me how many actually got added into that new interval. So you can find the difference between those bars to actually find out what's added into the new interval, but always make sure that you're starting with the beginning number on the intervals and going to the next ending value so that you can accumulate the data, because that's the whole purpose of the cumulative frequency histogram.